In this lesson, we will discuss the families of particles and we will go into the details of quarks and leptons. By the way, the list of quarks and leptons is not in your textbook. So, in the second edition of this Cambridge AS and A-level physics course book, that is in this chapter, chapter 16 is on radioactivity. The details of the leptons and quarks are not given. So, we will cover that part and also the classification. We will cover all of that in this video lesson on radioactivity. Again, like I said, it's in your syllabus, but it's not in your second edition Cambridge AS and A-level physics course book. That's why I am creating this video. Now here, if you look, this part is there, but again, this is all text. Very hard to understand. So because of that, I created a chart. Now with this content here, I created a chart which will make it easy for you to understand this lesson. Now, these notes are part of the complete Cambridge AS and A-level physics online course, and it's part of the radioactivity lesson. So students who buy the complete course will have access to everything. And now we are just going to go through this part on radioactivity, which is explaining this entire text here. Very hard to understand. I have put it in an easier form, into a table, into a chart. Then you can understand it much easily. And also we will see the classification of the fundamental particles, which are the quarks and the leptons. So you have to know the fundamental particles. There are 6 flavors of quarks, also called types of quarks and leptons. So 6 types of quarks and 6 types of leptons are there. Now before we go to that, we will go into the families of particles, which is what we have here. This here. Okay, and this is my note. So families of particles, we have hadrons and leptons. I have classified it as hadrons and leptons. Now quarks and leptons are the fundamental particles. Hadrons are not fundamental particles. Hadrons are made up of fundamental particles, which are the quarks. Hadrons can be further classified to baryons and mesons. Now, hadrons are made up of quarks only. Okay. Quarks are fundamental particles. So, this is very important. Leptons are also fundamental particles. Examples of leptons are electrons and neutrinos. So, we will go into more details of this when we learn about leptons. And we will go into more details of the quarks, or the types of quarks called flavors of quarks, when we learn about quarks in the next few slides. Okay, so families of fundamental particles, we have classified them as hadrons and leptons. Hadrons and leptons. Hadrons are made up of baryons. Hadrons are made up of quarks. Hadrons, which are made up of 3 quarks, are called baryons. Hadrons, which are made up of a quark and an antiquark. Now, antiquark is the antiparticle of quark. Okay, so even these leptons have antiparticles. So quarks have antiparticles, antiquark. So baryons are made up of 3 quarks. Mesons are made up of a quark and an antiquark. So baryons are made up of quarks, 3 quarks. For example, neutron. Neutron is made up of 1 up quark and 2 down quarks. We write it like this: UDD. Up quark, down quark, down quark. Proton is made up of 2 up quarks and 1 down quark. Okay, so examples of baryons are neutrons and protons, because they are made up of 3 quarks. Now, examples of mesons. Mesons are made up of a quark and an antiquark. We have the pi plus meson, which is made up of up quark and anti-down quark. So, if it's a meson, it's made up of a quark and an antiquark. It doesn't need to be its antiquark. It can be a quark and any antiquark. So remember, there are only 2 fundamental particles. One is the quark and the other is the antiparticle of the quark. Okay, another example is phi meson, which is made up of, for example, the strange quark and the anti-strange quark. Now, you might be wondering, what is this up quark, down quark, strange quark and all this? Like I said, there are 6 flavors of quarks. I think it will be better if we first learn the quarks. Okay, so we will go to that now. So here I have the 6 flavors of quarks. There are 6 types of quarks, or 6 also called types are called flavors of quarks. Okay, so this table is very important. You don't need to know the columns here. So you should know only the first two columns, okay? But I created this so that even the Edexcel students are taught using this. The Edexcel students need to know this these details also. The baryon number. Sorry, you need to know the first two columns and the fourth column. You should know the charge also. You don't need to know baryon number, and you don't need to know these. Okay, Edexcel students have to learn these other things also. So you all are Cambridge students. So you all need to know only the first column, second column, and we use simple letters for these also. Okay, so here they have written capital letters, but in the past papers, instead of the capital letter for the symbol of the quark, simple letters are used. So you always use simple letters, not capital letters. Then we have the charge. You should know this as well, okay? Because in the past exam papers, they have asked to find the charge and then determine which quark it is. So something like that. Now, if it has a charge of +2/3, it is an up quark. If it has a charge of -1/3, it can be strange quark. If it has +2/3, it can also be charm quark. Okay, I will teach you an easy way to remember this, how to remember the symbols, how to remember the charge. I will teach you an easy way of remembering this. Okay, quarks and leptons are the building blocks which build up matter, so that's why they are called the fundamental particles. That is, they are seen as the elementary particles, elementary or fundamental particles. In the present standard model, there are 6 flavors of quarks. They can be successfully account for all known mesons and baryons. Now, flavors are also called types of quarks. Now, here all 6 are given here. 1, 2, 3, 4, 5, 6. So, you should know these 6 along with their symbols and the charge. These are the 6 flavors of quarks, also called 6 types of quarks. And remember, hadrons are made up of only quarks. Hadrons are made up of, remember we saw the classification earlier in the previous slide. Hadrons are further classified to mesons and baryons. They can successfully account for all known mesons and baryons. The most familiar baryons are the protons and neutrons, which are baryons. Okay? Baryons, because they are made up of 3 quarks, which are each constructed from up and down quarks. You know, proton is made up of UUD, up quark, down quark. Neutron is made up of UDD, up quark, down quark, down quark. We saw it in the previous slide, previous note. Quarks are observed to occur only in combination of 2 quarks. Those are the mesons. We saw this in the chart earlier. 3 quarks, which are baryons. We saw this in the chart earlier in the previous slide. There are a certain claim of observation of particles with 5 quarks, pentaquark, but further experimentation has not borne it out. Okay, so you should know for now only the mesons and baryons, which are the hadrons. Okay, now how do we remember this charge and the name? Easy way. The symbol is the first letter. If it's up quark, it's first letter U. So the symbol is simple U. All these should be simple letters. For Cambridge syllabus, we use simple letters. Then down quark D, charm quark C, strange quark S, top quark T, bottom quark B. Okay. If you think of something affirmative, something positive, which of these words are considered to be positive words? Up is positive or negative? Up is a positive word, right? So up is positive. Charm, something like charming, you can remember. Okay? So that is also positive. Top means positive, right? So you can see all those are positive. Up, positive. Charm, positive. Top, positive. So they are like affirmative words, positive words. Up is something we can say like a positive word. Top is something like a positive word. Charming or charm, something like a positive word. So all those quarks have +2/3. Okay, and also you can see the charge is more here. Plus and +2/3. 2/3. Here all the others are negative. And negative, a lesser quantity negative, which is 1/3. So you can think of those as negative words. Down, strange, bottom are all like negative words, right? So they all have negative charges and they have the lesser amount. 2/3 is the major amount, 1/3 is the minor amount of the fraction. So remember, up, charm, top all have +2/3. Down, strange, bottom all have -1/3. So this is an easy way to remember the charge of the quarks. Okay, so now I think now already you remember the charges of these quarks and their symbols. So remember the 6: up, down, top, bottom, charm, strange. Okay, those are the 6 quarks you have to know. Then I will also show you the leptons. So there are 6 leptons, and the antiparticles are also there. So even the quarks have the antiparticles, antiquark we say. Okay, so these are the leptons: 1, 2, 3, 4, 5, 6. Okay, so we have electron and the electron neutrino, muon and the muon neutrino, tau and the tau neutrino. So we have electron, muon and tau and their neutrinos. It's easy to remember. So there are 3 things here: electron, muon and tau and their neutrinos. Electron, electron neutrino, muon, muon neutrino, tau, tau neutrino. All of these are leptons, and these are the symbols we use. Symbol for electron, that neutrino, we use this Greek letter. Again, by the way, I have created a video on the Greek alphabet. You can watch that. You will be familiar with all the Greek letters because we are using a lot of Greek letters in physics. Okay, so then we have that small e, which is the subscript e, because it's the electron neutrino. Then muon, then the mu, this is the Greek letter mu, and this is also a Greek letter, so we write the subscript because this is the muon neutrino. Tau, Greek letter tau, then tau neutrino. Okay, and their antiparticles are the electron, this is E minus, this is E plus. Then this is antiparticle, that's why we have the bar on top. So the difference between the particle and its antiparticle is only the charge. The mass, everything is same, only difference is the charge. Okay, so if it's muon, then minus here, plus there. Otherwise we use a bar on top like this, see. So tau, tau neutrino, tau, antiparticle of tau, tau neutrino, antiparticle of tau neutrino. So this is the electron neutrino, this is the electron antineutrino. This is the tau neutrino, this is the tau antineutrino. We use a bar on top to indicate the antiparticle. Now in this table, you have to know the first 3 columns only. For Cambridge AS and A-level physics students, only the first 3 columns are needed. The rest you can just forget, but Edexcel students have to know these other things also. Okay, so you all don't need that. Okay, then so now we have learned the types of quarks, types of leptons. So easy to remember: electron, muon, tau and their neutrinos. Electron neutrino, muon neutrino and tau neutrino, and these are the symbols. Okay, so remember the first 3 columns, study them in the exam papers, they can ask you. Then about the quark composition of the proton and neutron, this is something very common, so you should know it. In the exam papers also they are testing this. You would have seen this in the O-level class. Okay, so let's quickly go through this. The up and down quarks are the most common and least massive quarks, being the constituents of protons and neutrons, and thus the most ordinary matter. Proton is made up of 2 up quarks and 1 down quark. Neutron is made up of 1 up quark and 2 down quark. So U is for up quark, D is for down quark. And the charge, remember, if it's up quark, charm quark or top quark, the charge is plus 2 over 3 times the elementary charge. If it's a down quark, the charge is minus 1 over 3 times the elementary charge. Now, we have already seen the beta minus decay, beta plus decay. Over here, we have the beta minus decay and beta plus decay. See, in beta minus decay, what happens? A neutron becomes a proton. You should know this. This is also very important. In beta minus decay, this I have seen questions on this in the past papers. Previous we discussed a past paper and that had this question. Beta minus decay, the neutron becomes a proton with the emission of an electron and electron antineutrino. So this is, remember, the neutrino, and we can also use a small e there, the subscript e, to indicate that it is the electron antineutrino, because neutrinos, we have tau neutrino, we have muon neutrino, and also we have electron neutrino and the antineutrinos. You should know this equation. This electron here is the beta minus particle. Electron is identical to a beta minus particle. Then we have beta plus decay. In beta plus decay, proton becomes a neutron with the emission of beta plus particle, which is, this is the antiparticle of electron. Now remember, here we talked about the antiparticle of the lepton. So this is the antiparticle of the electron. So we can say this is beta minus particle, this is beta plus particle. Okay, so in beta plus decay, here we have beta plus particle. In beta minus decay, we have the beta minus particle. In beta plus decay, the proton becomes a neutron with the emission of beta plus particle and an electron neutrino. Here the bar is on top, which is the antiparticle. This is electron antineutrino. This is electron neutrino. You should know both of these equations. In the exam, you can have a question like this, and they might ask you what type of decay this is. Now here you can see the decay. It's giving a, this is alpha decay, by the way, because alpha particle is identical to a helium nucleus. So then you might have beta plus decay, beta minus decay also. Okay, so these are very important. Okay, let's go back to what we were doing. We were discussing this. Okay, so here you have beta minus decay, neutron becoming a proton with the emission of beta minus particle, which is the electron, and an electron antineutrino. Now here the subscript is shown, so this is very specific. It's all shown. They didn't have the subscript, so we don't know what type of antineutrino it is, but already we know if it's beta minus decay, it gives the electron antineutrino. So this is all. This has all the labels. It's very clear. In fact, the free neutron decays and nuclear decay by beta decay in processes like this. So beta decay means beta minus decay. So this is an example: phosphorus becoming sulfur with the emission of, this is, by the way, these are nuclear reactions, okay, not nothing to do with electron movements. So electron or beta particle, and this electron is, by the way, coming from the nucleus. Okay, remember that neutron becoming a proton, this reaction is in the nucleus. This electron came from the nucleus. Okay, there are no electrons in the nucleus, but when this change occurs, there is an electron created. So that's this. It's not an electron in a shell of the nucleus. It's in the shell of the atom. It's not from the shell of the atom. It's coming from the nucleus. This is also coming from the nucleus. This is the electron antineutrino. Is thought to be the result of a more fundamental quark process. So simply we can say, because the neutron is becoming a proton, see, UDD becomes UUD. So what happens? U and D is there, U and D. So only thing is the down quark becomes an up quark. Then this is the beta minus particle or electron, and this is the electron antineutrino. Okay, now let's go back to that chart and finish this off. Okay, so here you can see beta minus decay. Neutron becomes a proton. So neutron is what? It's made up of one up quark and two down quarks. Proton is made up of two up quarks and one down quark. So simply we can write the equation like this: down quark becoming up quark, and this also you saw in the other slide. This is the electron antineutrino. It has no charge and negligible mass. Electron has negligible mass, zero mass, negligible mass, and negative charge. Proton has this charge. So this is how we write it. Then also beta plus decay, we saw this earlier, and in the textbook we saw this also, beta plus decay. So proton becoming a neutron. Proton is UUD. Neutron is made up of one up quark and two down quarks. Okay, so we have this, and here this is the beta plus particle. This is the electron neutrino. So this we can write like this, because what changes here is one U becomes a D. One up quark, the middle up quark here becomes a down quark. Okay, so we can write it like this also. Then also you should know about the strong nuclear force, weak nuclear force. Strong nuclear force acts on quarks, act over very short distances, around this distance 10 to the power minus 14 meters, very short distances, explains alpha decay. So this alpha decay is due to that, we can say, strong nuclear force, holds the nucleus together. So what holds the nucleus together is the strong nuclear force. Then weak nuclear force, also called weak interaction, acts on both quarks and leptons, responsible for beta minus decay. So we have strong nuclear force and weak nuclear force. Weak nuclear force, also called weak interaction, acts on both quarks and leptons, responsible for beta decay. So we can say beta minus decay. Beta decay means, by standard, when we say beta particle, it's a beta minus particle. Okay, so that is the end of that lesson on particles under radioactivity. So the students who buy the complete course will have access to all of this, and some live sessions can also be included. For more information about our online classes, check the links in the video description. The entire Cambridge IAS and A-level physics course can be done online from any part of the world. If you're having an internet connection and watching this video, if you're watching this video, that means you have all the requirements to do our online classes from any part of the world. You can buy the entire course and do it online from any part of the world. And also, if you're watching this video, you can join our online live classes from any part of the world. For more information, for contact information, see the links in the video description. I have created several online courses. There is a link in the video description where you can see all the online courses that I've created. I've created online courses for O-level physics, A-level physics, O-level math, A-level math. Then there are small courses also. Some of the chapters are they are created into different courses and uploaded. So all the information is in the video description. You can also contact me if you want online classes, or if you have some questions about buying the courses. My WhatsApp number is there in the video description. You all also can contact me via Instagram. Okay, I hope to see you all soon in the next video, and I hope to see you all soon in an online class. Like this video, comment, subscribe to the channel if you haven't already subscribed, and share this video with someone who needs it. By the way, these are some of the notes in our online classes. So for every chapter, if I just go back here, for every chapter you can see there is a folder, and notes are created for each chapter with the video link. Now, for example, I have created a separate video, separate course or separate lesson that you can purchase for some of these chapters, like practical circuits, stationary waves, because students demanded it a lot. So I removed, from the entire course that I've created, I just created a separate course for practical circuits. Now if you go to that, see, these are all the notes, and there is a link to the video lesson. The video lesson may be 1 hour or 2 hours. That's covering all the theory lessons. So all the theory on that lesson on practical circuits, which covers internal. Wait, I will show you that one here. Yeah, so this one, see, internal resistance, potential divider, potentiometer. So this is what is covered in the practical circuits complete course. So if you buy the entire course, you will have the full explanation to the entire book. Then there are solved tutorials, there are solved past papers. You can download the tutorial, do it, and watch the video explanation of the tutorial solutions. Okay, so for more information about our online classes, check the links in the video description. You can also contact me if you are still skeptical about buying the course. You can go to my website, in the link is in the video description, where you can see all the courses that I've created. And by the way, this is what we have in the complete Cambridge IAS and A-level physics course. The theory lessons are there. There are past papers which are classified by topic with the solutions. Video explanations are available to the solutions. We can also discuss this in our live sessions. If you join our live online classes, if you don't want to buy the complete course, that's also fine. You can still join our online classes without purchasing the complete course. But if you purchase the complete course, I can give you some complimentary online classes. Then the paper 3 course is also created separately. You can buy the paper 3 course separately and do it online as well. A lot of students requested this, so I created this complete course where the students can do the practical lessons online and learn everything basically about that paper 3 online. Paper 5 is there. Then there are solved exam papers. There are hundreds of papers that have solved from earliest years to latest years, and you can watch those papers also. This is part of the complete course. Then there are other resources. Then there's explanation to the course concern, how to use this course. So check the links in the video description, and I hope to see you all soon in an online class and in the next video. Share this video with someone who needs it. Leave a comment, subscribe to the channel, and if you buy our courses, in a very short time you can improve a lot. There are thousands of students who have been C and D grade students, and in a very short time they became A and A students by using our online classes and also our physical classes, online courses. So you can check the reviews on the website. So again, the links to the websites are in the video description.